So let's look at a couple more problems with word problems involving sequences. So in this case, we have that Scarlett bought an ant farm with 80 ants. From the following week forward, the ant population tripled every week. Let G of n be the number of ants in Scarlett's farm in the nth week since she got it. So we need to find what kind of sequence this is, and we need to find what the explicit formula is. So since it is tripling every week, it's multiplicative. It is multiplying from one term to the next, which we know is geometric. But let's write out a quick table here of what our sequence looks like, and we can generate the values ourselves. So let's say we have n, the term number, the week since she got it, and we have the sequence g of n. And we know that in the first week since she got it, she had 80 ants. But in that second week since she got it, it tripled. So 80 times 3, now she's at 240. In that third week since she got it, it's tripling again. And 240 times 3 would be 720. And so it's just going to keep multiplying by 3 every week forward. And from this geometric sequence, we just need to remind ourselves what the general formula is for these explicit formulas. So in explicit formula, g of n, it's always going to be equal to the first term of the sequence multiplied by r, our common ratio, raised to the n minus 1 power. So r is just that common ratio, the number we are multiplying by to go from one term to the next. And of course, since it's tripling, we know that each step of the way we're multiplying by 3. So this right here, this is our r value. And we know the first term, that is 80. So we can rewrite our explicit formula, g of n, as that first term, 80, multiplied by 3 raised to the n minus 1 power. And it's a good habit just to check these. So we want to check to make sure our formula is correct. And we can choose whatever term value we want. Let's just say at the third term, we know it's supposed to be 720 ants. Or essentially in the third week since she got it, there should be 720 ants. But let's make sure that works in our formula. So we have that g of 3 is equal to 80. So n is equal to 3. So we have 3 raised to the 3 minus 1 power, or 3 squared, which is 80 multiplied by 9. And 80 times 9 is 720. So the formula gave us what we expected, which means we can feel fairly confident that this is indeed correct. So this is what we'd put into our box here, and of course we know it's geometric. Let's do one more. And for this one, I might pronounce the name wrong, but let's say Zhang Li tracked the size of the bear population in a nature reserve. The first year, there were 1,000 bears. Sadly, the population lost 10% of its size each year. Let f of n be the number of bears in the reserve in the nth year since Zhang Li started tracking it. So since we're losing a percent amount each year, we are essentially multiplying by a number less than 1. In fact, if we're losing 10% each year, that just means that 90% remained after every year. So we're going to be multiplying by 90% to go from one term to the next. And since we're multiplying, we are again looking at a geometric sequence. And for this one, we need to figure out the recursive formula. But let's first generate what the sequence would look like. So n, that is our nth year since he started tracking it. And our sequence, in this case, is called f of n. So let's make a quick table. So we know that in the first year, since they started tracking it, so n is 1, that the population was at 1,000. But in that second year, the population lost 10%. So 10% of 1,000 is 100. So it lost 100. Now it's at 900. And in that third year, the population again lost 10%, and now it's 10% of 900, which is 90. And 900 minus 90, now it is down to 810. That fourth year, losing 10% of 810, so that's 81, we're going to take 810 and subtract 81. And of course, this pattern keeps going. But notice, like I mentioned, from one term to the next, we are essentially just multiplying by 90%, or 0.9. So every step of the way, we multiply by 0.9. This is our R value, where R is our common ratio. And so for this one, we need to come up with a recursive formula. So remember, with a recursive formula, if we look at the general form, f of 1, that is our first term, which we already know, that's starting at 1,000. And then we have the pattern, that to find the nth term, we'll take the term before that, f of n minus 1, and then multiply by that common ratio, where again, r is our common ratio here. Since we have a geometric sequence, we're multiplying from one term to the next. And so we just need to match up with what we know as r into this pattern here. So since it's geometric, we are going to be multiplying, and we're multiplying by 0.9 to go from one step to the next. Now, we can check to make sure that this works. So to check this, let's just find the second term. Since we know that f of 2 should be 900. So based on this formula, we're going to plug in n equals 2. And we have f of 2 is equal to f of 2 minus 1, which is the first term, multiplied by 0.9, or 90%. And the first term we know is 1,000. And 1,000 multiplied by 0.9 is 900. And that's what we expected, so we can feel very confident that this formula is correct here.